Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a Marantz 2216. Very nice example of a Marantz 2216, yes. Now this is a client unit. He brought it to me. There's a story behind this, a little bit of a story. The city where my client lives, they don't have a lot of options for vintage auto repair. So he had somebody do some work to this, replace some caps, put LEDs in, and did some work. But he got it back and he listened to it and he's not happy with the sound. It sounded terrible to him. He says it sounds like crap. So he brought it to me and says, what can you do with it? And I says, well, I'll have a look at it. I don't know. It should sound better than what it does. Now, yesterday I had this receiver connected and I listened to it and I confirmed it does sound like garbage. It's terrible. The bass is all muddy and boomy and there's no clarity in the highs. It's really mushy sounding highs. It does have a good frequency response, but it's really a mishmash of different noises, and I don't know if it's a high distortion or if it's just or what it is. You know what it sounded like to me? It sounded like it had bad caps in it. So, what do I do? Well, I tested it out on phono as well, and it sounded equally as bad, even worse. So, FM wasn't great. These knobs are loose. I have to fix that. So, I told him I'd have a look at it and see what I could do. Let's have a look inside and see what was done. Alright, cover off, have a look. A little heat stain in the center there, that's right above this power supply here. Okay, so looks like these two caps have been changed. These ones here look all original. This one looks changed, and maybe that one. But then these other ones, so it's a partial recap. I see 1, 2, 3. Looks like he did all of the caps in the power supply. Now this is unique. You have two 47s at 63 volts instead of 100. It's unusual. This here looks like phono stage. This looks all original caps. Tuner. Tuner looks all original. Yes, all original in the tuner. And do we have a tone board underneath maybe? Yeah. So I did have a look on the schematic. And this thing is just loaded with interstage capacitors. You know, we have the output blocking capacitors. These were specified in the schematic as 3300 microfarad. And I can see that somebody put in 4700 microfarad at 50 volt. Okay, that's all right. That's fine. But these input caps here have not been changed. This has got tantalums here. And this power supply, I'll have to check, make sure we have all the right values. Interesting choice of different caps. But I've listened to many amplifiers that have capacitor coupled outputs and they sound fantastic. So this is no excuse for having poor sound, having a capacitor coupled output. So let's get to the bottom of this. I have a feeling it's interstage caps in the tone amplifier that are just mush and completely shot. So, and here's our build date, 1977, May 27th. You pull the bottom off and see what we can see under there. Okay, here's the underside. It's a tone board here. And yes, it has all original caps on it still. So as part of my listening experience yesterday when I first plugged this in and turned it on, is I was greeted with a loud hum out of both channels It didn't sound very healthy, and then the hum quickly kind of quieted down as if the capacitors inside were reforming. And that was kind of troubling because it shouldn't do that. It shouldn't make that noise on power up. Another problem with this thing is I was listening to it and one channel would cut out and turn to distortion. So you go to the left side and you would hear the music, but it would be all distorted and quiet. And you play with the switch, it would come back, maybe it wouldn't. Tape monitor switch is problematic. The selector function switch here is problematic. The speaker switch is problematic. The potentiometers were okay, they didn't scratch, but these four were problematic, and I'm gonna have to go in and service all them, and I'm gonna have to do a full meal deal on this. The capacitors that he changed, I'm gonna check and make sure that they're all the correct values, and if they are, I can just leave them alone. Some of these, like this double 47 microfarad, I probably want to remove that and replace it with a single 100 microfarad cap. I don't know, I might leave that. I don't know if it's okay. Yeah, so we're going to go through and check all this and make sure it's all good. I have a feeling all these old caps that were left behind are the problem. One thing I want to do is hook it up and do some tests. Okay, so what you're looking at is you're looking at my old analog scope, and what you have here is 1,000 hertz tone on the is this X or Y axis? I can't remember the difference between the two. So this is the signal I'm feeding into the amplifier, and then the signal coming out of the amplifier is going to be horizontal. So when I turn on the amplifier, you'll see the line will change as the amplifier comes alive. Okay. And then as the amplifier wakes up, it becomes a 45-degree angle. So that means that the output signal matches the input signal and creates a straight line. You can't really see any distortion. You can see a little bit at the tops and bottoms where the lines separate. But I'm going to demonstrate here. This is bass cut. I'm going to turn the bass down. Okay, so that's bass cut, bass boost. They look the same, but believe me, they're out of phase with each other. And this is going to be treble cut. This is 1,000 hertz tone and treble boost. Okay, so we're going to set our controls to absolutely flat. And I'm only doing one channel here. I'm doing the left channel. So if I hit the balance, our signal disappears from the amplifier. So what I'm going to do is I'm going to go up and down in frequency. This is 1,000 hertz tone. This amplifier shouldn't have any problems at 1,000 hertz. So let's go down 9, 8, 7, 6, 5, 4, 3, 200. Now you see we start to run into a problem here. At 200 hertz, this is distortion. If I take it up to clipping, you can see how the amplifier starts to clip on top and bottom. Okay, that's not what we're wanting. What we want is let me reset everything. Okay, at 200 hertz you can see how these lines are starting to separate. So what's going into the amp doesn't match what's coming out. That's what that line is telling you. So let's turn this down some more. Here's 120 hertz. If I play with the bass control, you can kind of fidget with it and make it sound better. Let's go down 100 hertz, 70, 60 hertz, 50, 40, 30, 20. And 20 hertz, we have pretty bad waveform. What's coming out of the amplifier does not match what's going in whatsoever. It's a completely different signal. So that's where we're getting a lot of our muddy bass from. So let's go back up. Let's go back up to 1,000 hertz. Okay. Now I'm going to get the top end of the spectrum. We're going to start going up in frequency. And we're going to see how this thing does. Might have to turn this down a bit. So I am getting close to full power here. So let's go up. 2 kilohertz, 3, 4. And we're at 4 kilohertz already, and look at the lines are separated. If I play with the treble control, we can kind of bring it back in. But all we're doing is compensating for a deficiency in the amp. Let's keep going. 5, 6, 7, 8, 9, 10 kilohertz. 11, 12, 13, 14, 15, 16, 17, 18, 20 kilohertz. And look at this. Same thing. It does not look like anything that's coming out. It doesn't look like anything that's going in. Let me try that treble control here. Doesn't even do anything to the signal. Can't compensate for that much error in the amplifier. So we have a lot of problems, and I think it's probably caps. Let me turn this down. I'm going to do the same test on the other channel and see if it's the same. I have a feeling they're a little bit different. Okay, here's the same test on the right channel. Let's turn the amp on. Wait for it to come alive. Okay, this is 1000 hertz tone, and I already see a problem. We have quite a difference here between our input and output signal already, we can see. And playing with tone controls isn't the solution. So let's go down in frequency. Yeah, it's getting worse. 200 hertz, 100 hertz. Why does it look so different? Let's go down slowly. Seems like it's coming back. Here's 70 hertz. This thing's a mess. 30 hertz, 20 hertz. 140 hertz. Going back up, 200 hertz. Okay. Let's go up on the high end of the scale. 2 kilohertz, 3, 4, 5, 6, 7, 8, 9, 10. There's 21 kilohertz. If I keep going, it just gets worse and worse. This amplifier definitely has problems. So yes, I think a fresh set of caps will wake this thing up and make it behave properly. I think there's limited frequency response on both the low end and high end range of the spectrum, and I think that's from bad caps. Now it does have capacitor coupled outputs on the amplifier, which is kind of bad news for low frequencies. It doesn't handle very low frequencies well, like the 20 hertz, the 10 hertz, the 30 hertz kind of frequencies I'm talking about. It really struggles. The frequency can get through the cap, but there's still attenuation within the cap at those frequencies because it is a low frequency, and caps aren't intended to pass DC, they pass only AC. So let's get this thing recapped, and I'll go through and check everything. There's not that many in here. I'll do the tuner as well, because I did test the tuner and I wasn't happy with the performance of the tuner at all. It was yeah, it's pretty lame. Now I think after I'm done with the recapping, we're going to do that same test again, and we're going to set it up and we're going to see how much of an improvement we made. To me, this is the only way you can really test an audio amplifier, is to compare what's going in with what's coming out, and from that you can determine how much of it's distortion and how much of it is frequency loss or loss along the band. So let me get started on this, get my soldering iron warmed up and get the caps ready, and we'll start plugging them in. Okay, update time. So I'm going through doing caps on this power amplifier. These 4 caps here, the previous tech replaced 2 of these caps, 1 on each side, but these 4 caps are these giant orange drop, and these are low noise caps. They're Masashita MRZ brand line of caps. These are 100 microfarad 35 volts. They had installed 100 microfarad 50 volt Ninchicon. Nice quality cap. It's good condition. Everything's fine. But these 2 caps need to match, and they don't match whatsoever. You replaced one of them and left the other one in. They're anything but a match. And if you look in the schematic, I don't know if you can see this. I'll try pointing it out to you. Try moving it close here. This cap is here and here. So what I did is I removed the 2 new caps and the 2 old caps and replaced them with 4 caps that match in value and in voltage, so that it should be a little more stable now. Not that it wasn't before, but I have a feeling these 4 caps are critical for the feedback loop, and they provide filtering there. Now, the other caps, not really anything to mention. I left these 2 main speaker output caps in place. They're okay. And leave them alone. Now, onto the power board. I found a lot of discrepancies. This cap here is... Oh, sorry, let's start with this cap. These 2 caps are 47 at 63 volts, and they're wired in parallel. And this is supposed to be a 220 at 50 volts, according to the schematic. So I'm going to have to remove that and upsize that again. This one's 220 at 16. I think that cap is fine. This one here should be a 330 at 50, and they put a 220 at 50. So that one's undersized, and that one should be changed out. This one here should be a 220 at 50, and they put in a 470 at 63, which is oversized. So I could probably take this cap, move it over here where it belongs, and then upsize this one. If I just swapped the place of these 2 capacitors, I think that would fix that. This one here is supposed to be a 330 at 35. I think that one's correct. And then a 470 at 16. I think that one's correct as well. Yes. So I'm just going to swap these 2 caps, and but he's got them glued down to the board pretty well with some kind of weird adhesive. So I'm going to have to dig that out. So I'm going to do that next, and then onto the phono stage and then tuner. The tone board is done. Replaced these caps, and it all went well. And then we're going to be done recapping. It's not that much to do. Look at the glue they used on this. Oh! Wow, it is something else. It's some kind of a... I don't think it's not silicone, but it's definitely... And then I gotta clean the board off because all the old glue is still there, and then they just glued on top of it. So I'm gonna clean this board up. So I decided just remove all the caps and then clean this board off. It's just flooded with that nasty glue, and yeah, I think it's all gonna come off. It's just, look at this stuff. Isn't this lovely? Yeah. Alright, so the recapping has been completed. It's all done. Any other mods I did? Yes, I did other mods to this, and I didn't mention I was going to do this, but I added bypass capacitors to some of the main capacitors here in the power supply, the power amplifier, the phono stage, the tone amplifier. So wherever power comes in and it hits a bulk filter cap, I added a 22 or a 220 nanofarad or 330 nanofarad bypass capacitor just to help. I don't know if it's going to make any difference or not. So this thing has been completed with capacitors, not that many, as you can see here. Now, I just want to say I never did find that smoking gun that caused what I thought would be the main culprit of all the bad audio in this thing. I think it's just a combination of all of the caps. So I don't even know if this has been repaired yet. So what I think I should do is connect this up and listen to it right now and see if the sound is improved, because it did sound horrible before. I just want to test it, see if anything's improved with what I've done to this receiver. So give me a chance to do that, and I'll report back what I find. Okay, so I gave it about half an hour on the desk there to listen to it, and I got to report the sound change is dramatic. This thing is actually sounding a lot better than when it did when it first came in here. I can now hear the center channel of the music coming at me. Before I couldn't hear that, and the stereo separation was terrible before, but now I can hear the separations improved quite a bit. The bass is not just a mumbled mess. It's there, and it's more precise. It still gets boomy, especially when you crank it up, but you know, that is capacitor coupled outputs. You can't get away from that. So I think what I've done here is a huge improvement. Even the tuner is now working properly, and it sounds great. So yes, get rid of these old caps, because they're not doing you any favors by hanging around. Now I still haven't even set up the bias on this yet, which is kind of, I should have done something about that before I did my listening test, but I'm really quite impressed on the dramatic change here. I did clean the speaker switch, which I think helped, because I didn't have one channel cutting out on me. So that's improved, but I still need to clean the function switch and the tape monitor switch. So I'll do those two. The potentiometers are good. I didn't touch them, and they are not scratchy, so I'm going to leave them alone. The tuner's improved quite a bit. I don't think I'll do an alignment, because it sounds like it's working a lot better than what it was. So I'm going to leave that alone. I still want to go through this power amplifier and check a few things though. It looks like it has the original silicon in it. But I still need to set this up, bias. Okay, bias is supposed to be set at 4.5 millivolts, and we're measuring 10 on this channel anyway. So let's turn this one down a bit. Now, increasing bias is not going to affect the sound quality. It's just going to consume more energy in your amplifier. Having too little bias will affect your sound quality. So, since it was high, I didn't expect it to make a difference on how it sounded. So when I turn this down, I think it's going to sound the same. I'm going to leave it at 4.6. I'll come back and tweak it. Let's try the other channel. And they want you to measure across R735, 736. That's one of the emitter resistors. And they got a little loop here on the resistor end of the body you can connect your thing to. It's really nice. Okay, let's get this side. This side's up at 10 too, so let's turn this one down. Turn these both down to 4.5, and then we'll see where we're at. Look at what this thing's consuming on idle. 12 watts. It's perfect. So I'll let that stabilize, and I'll tweak it till it's 100%. So I removed the heatsink just because these are dry. Looks like they use some kind of grease, like, you know, that stuff you put on your lips that's to keep them from getting chapped? That's what it feels like it's on here. So I'm going to clean all this off, put some fresh grease on, and put this back together. I just wanted to clean this up and make sure it's properly heat sinked. Here's a trick I've never seen before. You take the burned out lamp and solder fuse or LEDs directly to it. Your dropping resistors. Looks like they have back to back. Let's see if they're polarized. No, they're polarized the same way. They're polarized the same way, but they have dropping resistors added. So that's kind of interesting. Never seen that before. So anyways, I'm going to add some diffusing. This is diffusing sheet that I scavenged this out of an old LCD monitor. And you can see it's almost like polarizing. But this will diffuse the lamp, these 2 point sources, and it'll make it a little better. Alright, let's do this power test. I have it all set up for 8 ohm load. Let's turn it on. And I do have a tone going in. I just want to hear things first, so let's put the volume up a little. Just want to confirm all the controls are working. Okay. Alright, so we can turn off that noise. We'll turn on that. Let's turn this up. Alright, let's... Ooh. Okay. So we have 1000 hertz tone. Let's keep going. Here's our clipping. Left channel clips long before the right channel. I'm going to place it right about there, and we're going to run with that. Start the timer. Okay, so we have 14.25 volts RMS on the output. I know that doesn't look good. Might have to do a little bit more work to this amplifier. Let's just see how it goes once it warms up. Turn it down to there. 13.22 volts RMS. Here's our power consumption, 92.5 watts, somewhere around there. I'll let this go for a while. Okay, we're coming up to 10 minutes, and I just want to take some readings here. Heatsink says it's at 52. I have that hard to believe because, well, maybe. It's pretty... Yeah, it's slowly climbing up. It was doing 45, now it's at 50, 52. So after 10 minutes, it's about 52, 55 at the most, which is not bad. I'm going to turn this down. I think it's done its job, and I think it's working well. So let's try a couple square waves, and then we'll go move on to other tests. Okay, here's square wave. And go up to full power, and it starts clipping right there. Can't really see because they're overlapping, but okay, let's turn this down. We don't need it that high. Let's turn this down. Okay, so this is bass cut. Bass boost. So it's got really not a linear bass response. That's why I think it sounds so terrible on the low end. Treble cut, treble boost is working good. Balance is clean. Loudness. Okay. Let's try going up in frequency. 5 kilohertz. Go a little higher. 10 kilohertz. It's not bad for a capacitor coupled amp. Let's go higher. You start to lose it right about here. And that's 29 kilohertz, yes. Let's do the low end of the spectrum. $300. 200, 100. Now we're starting to see the effect of the capacitors. If I boost it, it doesn't really correct for it. It just kind of goes bleh. And that's a bass boost, bass cut. Let's go down. We are at 100 hertz right now. Let's go down. 40. It's just looking worse and worse. That's what you expect for a capacitor coupled output. Alright, so after that last power test, I'm kind of convinced that there's still a problem in this power amplifier. Seems like the right channel has a problem, because it is clipping early on the lower portion of the waveform, which suggests maybe a PNP transistor's maybe leaky or damaged, or maybe a driver transistor. So what I'm going to do is I'm going to pull this heatsink back off again, and I'm going to start poking around at these transistors. Maybe it could be a resistor out of tolerance too, I don't know. But we're going to get to the bottom of this, and we're going to make sure that this amplifier is working 100% before we give it back. So let me start. Yeah, I can start on this. I'll check the resistors first, and then we'll go after transistors. Okay, so I didn't have to look very hard to find the problems, and here it is. These are the output transistors for this amplifier. You got the left channel here on the left, right on the right. So there's a Sanyo D313, has a gain of about 131, and Sanyo B507, gain of about 108. Now these have an E classification for gain range, so that should be between, ouch, so it should be, this is for the 2SB507, 2SD313. Okay, so here's our HFE class. E should be between 100 and 200, and we're still between, we're right at the edge, 108 and 131. So that's not our problem, that's the left channel. Left channel is working fine. Here's the right channel. Here's the 2SD313. It's got a gain of 145. 2SB507, gain of 42. This transistor's failed. That's why we were getting early clipping on that one half of the waveform on that one channel, because of this dead transistor. Now I do have 2SB507s, brand new ones. This one came back at 155 on the gain, but I could do this, replace that, and be done with it. But I think I have a better solution here. I think I'm going to do something like this. I'm going to get all new transistors, D44H11, D45H11, so it's a matching complementary pair. I'll get 4 of these babies in, and I think this will really make it wake up and sing. I've done this on other amplifiers. I've used these ST transistors, and they are good transistors for audio work in this power range. These are heavy duty too. These are up to 10 amps, where these older old ones are only good for up to 3 amps. What does it say here? Collector current is 3 amps. VCBO is 60 volts. So, you know, these are 80 volt transistors, 50 watt, 10 amp. So these are a lot beefier transistor in the same package. So I'm going to go with 4 of these, I think, and put this thing back together. I also want to check some of these driver transistors in here too, because I didn't pull any of these out to test them yet. I might as well pull them all out and test everything, just to make sure there's no bum transistors slip through the crack here. And then this receiver will sound great. Alright, before I do a power test, I want to reset the bias because it is all changed now. Got new transistors in, and this is what it reads, 1.9. So we got to turn this up to 4.5. This thing's been turned on for about 15 minutes. Just going to slowly turn it up to what it should be. Right about there. Okay, let me check the other channel. This one's low too. I guess replacing output transistors upsets the bias. So let's turn this up again. Okay, I'll let this stabilize, then I'll recheck it, and then we'll do our power test again. Okay, so I'm all wired in to do power test here. This is just going to be quick and dirty. I want to see if our problem with the power amplifier went away. I'm going to take it up to full power and see how the display looks, and then we'll take a power measurement. I have a feeling we're going to have a little bit of improvement. Improvement in both where it clips, and improvement in sound, I think. So let's let me put you on the scope. Too lazy to set up 2 cameras, so this is what we're working with. Okay, so here we go, going up in amplitude. And where is clipping? Oh, clipping is... Okay, so it looks like both channels are balanced now. And we get clipping on the bottom before the top. So let's back off on, let's do the left channel. Right there, I think. And we got 14.12 volts RMS on the output. That's a lot better than what we were doing before. It's amazing what a new set of transistors will do for the output. Okay, so I'm going to end this test here. Let's have a quick look at our comparison here. We got our signal. Let's turn the amplifier on. Let's see here, turning it on right now. Okay, up the volume. Okay, so we have a little bit of difference between one line and the other. I'm doing 1000 hertz tone right now. So let's go up in frequency. Let's see how we do. That's 5 kilohertz, 6, 7, 8, 9, 10, 11, 12, 20 kilohertz. And treble cut, treble boost. Now you guys are probably saying, well, what the hell are you doing, Trevor? All you're doing is you're measuring phase shift. Well, yeah, you're measuring phase shift, but you're also measuring the difference between what's going in and what's coming out. Let's go back down to 1 kilohertz. Okay, let's look at the low end. 900, 800, 400. The lines are starting to separate. 3, 2, 1. 50 hertz, 60 hertz, no, that's 30 hertz, 20 hertz. I think it's better, to tell you the truth, because before we were getting, this is 370 hertz right here, 400, and we go up. It was behaving all the way up to about this point, which is 4 kilohertz. 400 hertz to 4 kilohertz. We have pretty stable line. The phase shift is not there, and everything looks good. So I'm going to leave this one. Let's see the loudness control. Let's see what that does. Yeah, see what the loudness control does. That's 0 volume, turning it up, 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 up. Hit a spot where it's a flat, where it doesn't change. Taking the loudness off. That's full power. Okay. Well, that's it for this one. I'm going to end it here. I think I've accomplished quite a bit. It actually sounds a hell of a lot better than when it came in. Now, it's hard for me to translate that to you guys on the YouTube video. How does it sound? Well, it sounded terrible. Yeah, it did. Now it sounds great. But you guys can't experience that because you're not here with me. And I tried doing a little bit of experimental measurements there, and it kind of shows the limitations of the amplifier. But we did some repairs, and while it didn't really look like anything changed, I assure you, this thing does sound a lot better. Now, this is not a powerhouse. This is only 20 watts a channel. It's got some capacitor coupled outputs, which limits its ability to perform low frequency reproduction. And but it is a good sounding receiver. Now, if I'm going to return this to the customer, and hopefully he's pleased with it. There's not much more I can do for it if he's not. So just going to let it go at that. But thanks for watching, and take care. We'll see you on the next one.